Well, I just realized that question number 14 is the same as question number 11, so we're not going to do that. So welcome back to our videos for the chapter 3 review for Math 151. Starting with problem 15, this is the last of the review videos. It says find all of the asymptotes and intercepts and then sketch a graph of the rational function. So we're going to find the asymptote and intercepts. So y-intercept is the one that's easiest to start with for me, because that's when x equals 0. So that's a negative 4/3. So 0 and a negative 1 and 1/3. The x-intercepts would be when the numerator is equal to 0, so there are none. There's no x-intercepts. And the vertical asymptote is when the denominator is equal to 0, so x minus 3 equals to 0, or x equal to 3. So that's the vertical asymptote. And then the horizontal asymptote, if there are any, is when we look at the degrees. So there's a 0 degree on top and a 1 degree on bottom. So the bottom is growing quicker. So then the horizontal asymptote is at y equals 0. And it looks like this right here. Okay, number 16. Let's look at the y-intercept. So f of 0 is it's going to be 0/3 is 0. So we have that point. And then my x-intercepts are where my numerator equals 0. So that's just when x equals 0. So the same point. My vertical asymptote is when my denominator equals 0. So that is x equals a negative 3. So x equals a negative 3 is my vertical asymptote. And then my horizontal asymptote is at y equals 2. Y equals a negative 2, because the exponent's the same degree on the top and bottom, which is 1, so that we're just looking at the ratio of the coefficient over each other. So negative 2 over 1 is just a negative 2. And then that graph looks like just like that. Here is that asymptote at a negative 3 and a negative 2. Okay, then number 17, we're going to look at the y-intercept first, which is going to be 3/0 squared plus 4 times 0 minus 5. So this is actually going to be at a negative 3/5. And there's no x-intercepts because the numerator can't equal 0. And the vertical asymptote, we're going to factor this to see where that equals 0. So that's at x minus, or x plus 5, x minus 1. X minus 1. So we have vertical asymptotes at x equal a negative 5 and x equal a positive 1. And then the horizontal asymptote is going to be at y equals 0, because there's no degree on top and the denominator is 2, so the denominator is growing much faster than the top. So that's why there's a horizontal at y equals 0. Okay, and the last question, number 18, says the radius of a right circular cone is 2 inches less than its height. Write and solve a polynomial equation to determine the height of the cone such that the volume is 96 pi cubic inches. The volume of a cone is this. So write and solve a polynomial equation to determine the height of the cone such that the volume is this. So the volume is going to be 96 pi 1/3 pi. The radius, they said, is 2 inches less than its height. So it's the height minus 2 squared times h. The radius is 2 inches less than its height. Okay. So first of all, I'm going to multiply both sides by 3. Get rid of this fraction. So when I do that, I'm going to multiply here by 3. So I get 288. And my pi's just cancel each other out. So I've really got h times h minus 2 squared. So I've got h times h squared minus 4h plus 4, 288. When I multiply this through, I've got h cubed minus 4h squared plus 4h minus 288 when I bring it over here. And on these, there's no reason why you can't just use your graphing calculator. And when you put that into Desmos, you can see that the height will be at 8 inches. Cubed times 4x squared plus 4x minus 288. I'm going to zoom out so I can look at this, and we can actually just click on it there. There's the x here, and that's the x-intercept. That's the only thing we're looking for, which is the 8 inches. So that is the end of the review for chapter 3.